Okay, just a reminder here. Dun dun dun. That's all you've got left this term. Okay, also notice the board. I need your stuff by Thursday midnight next week. If you want it on this term, Thursday midnight next week. And I'm cutting off. Okay, also notice the days I'm going to be here after school. Okay, I'm also have freed up next Thursday lunch as a review before the test. Okay, I will bring the dessert, you bring your lunch. Yes.
Wait, today?
Next Thursday.
Okay, also, will you be here after school tomorrow?
No, I won't be here at all tomorrow. At all. Okay, and I won't be after school on Thursday, but I will be Friday, and if you need me to be longer on Friday, I can. The regular chemistry tutoring after school on Thursday in Mrs. Hultry's room tomorrow because I won't be here. Thursday because I won't be here after school is there. I've got to go to the training at River State. Okay. All right, so here's what's the plan. We're going to go back over C part today in lab. So we'll do a real quick titration, review your brain, and then we're going to do the titration with the pH meter. Okay, so we want to do it really quick with the new chemicals because we don't know how much it's going to take with new chemicals. So that's why we're going to do a quick one first. Then we're going to do the one with the titration with the pH meter, and you can print it out. If you get to the next part, great. You can go on and start doing your buffer part. It's all out. Or you can ask to do the titration of the beverage if you get done in time, and you want to do that. Or you can finish part B. That's still in the hood for a lot of you. Okay, so there's a lot to do. Next time, we'll work on this. I'll give you the salts, the Kas, and the buffers, a little quick lecture on that. Then we'll go back in the back and we'll do the buffers and we'll do the beverage and the vinegar. Then I have set Monday, I think that's Monday, as a cleanup day. It might end up being a lab day. It might not end up being a lab day, whatever. I will probably give you the review that day. And then we'll go over the review in class on Wednesday. And it will also be a get your crap together, get done.
This Wednesday or next Wednesday?
Next Wednesday. We won't be in class this Wednesday. Okay, so that's sort of what's going on. And then exam 9 will be Friday next week. Okay, so that's what's up there. So you can sort of look and see what you got to do there. You can look at the old review from last year. It's already up on the tutorial and the review I did with them. Last year's already up. So I'll do a new one with you that includes the extra 25 questions she added this year on the test. Okay?
Wait, so is this
Which is better. It's 50 questions, which means that each question is only 2 points, where last year each question was worth 4 points. If you missed one or two, if you missed two, you were gone. So you have a better chance this year because there's more questions. Okay, so that having been said, we're going to go really quick into notes. Shh. Okay, you got to move fast, so I don't want to talk over you. We are going to go back over this in lab. I'm going to have it up so you can see it. I mean, shush. Okay? All right. Acid rain, there usually is some kind of, when people talk about acid and base, you want to talk a little bit about acid rain. By the way, it's right here where we're basically starting, I believe. I don't think we have anything on this page. Well, the acid rain is down at the bottom of this page. So if you're looking for the pictures, this is the picture you're looking for, bottom of the page before it. Okay, so really quickly, sulfates. You have SO3, which is sulfur trioxide. Hits water. You get sulfuric acid. That's a pretty strong acid. Nitrates, the nitrogen dioxide hits water, we get nitric acid. That's a very strong acid. So if these two gases are allowed out in the air, we end up with very strong acids coming out. Carbon dioxide, everybody's worried about as far as acid rain, but it makes a very weak acid, which is carbonic acid, mostly stays together. Okay? Actually, for the most part, the equilibrium is back this way. It goes back to carbon dioxide and water very quickly. Okay? The big bad ones are the nitrates and the sulfates. As far as acid rain, as far as
Sulfur. I can have the acid that give it actually some burn noise.
yeah. So there are places over in Europe and Germany where the rain is so acidic that they have to be inside when it rains. And the forests are killed and everything is having problems growing because of pollution. It starts melting your houses on the outside if they're made of brick. Okay? All right, going forward here. Water can self-ionize. You need to know that. Water can self-ionize. That means it can take two regular waters, and one acts as an acid, one acts as a base, and we get an acid and a base. What type of acid is this? Whose definition of acid is this? We had 3 last time.
Lewis.
It's not Lewis. Lowry. Ronstadt and Lowry had a theory. Remember that song that you were broken up?
No.
Okay. Remember, Ronstadt and Lowry get positive and minus. Okay, on the product side, that's a hint. You know it's Ronstadt Lowry. If I get a water and salt, it's Arrhenius. If I get one thing, it's Lewis. Okay, so remember that. Okay, going forward. When water self-ionizes, this is what we get. This bracket means concentration. It means molarity. Whenever you see a bracket, it means molarity. The concentration of acid versus concentration of base in normal water is 10 to the negative 7 molar to 10 to the negative 7 molar. You need to know that. Basically, that means it's going to be a pH of 7. Top number, okay? If I times those together, I'm going to get 10 to the minus 14. You need to know this. This is known as Kw, or the K of water. This is something that is used a lot in chemistry. Okay, so we want to know this.
So when would we use this?
I'm going to show you in just a sec. Okay, so these are the ones that we need to know. Now, last time I gave you some cards that look like this. Did anybody not get a card? Okay, I'm going to pass them around. If you haven't got one, grab one. Some are colored, some are not. So okay, this is what you're looking at right here, okay? I'm going to just put it right like that. Now, I don't like, okay, guys, you gotta be moving. I don't like this equation for going back and forth, but if you are given OH and you're asked to find H3O plus, you'll often see it just said H plus rather than H3O plus. The movement is now to include the water in the H plus, saying it's H3O plus because it actually is together. So you'll see me calling it H plus or H3O plus, same thing. If they want you to find it, this is, you've got to be careful. Okay, you've got to be careful. Everybody got your calculators out? How many need a calculator? I'll run them around.
I don't even get mine. And it's not that hard to get
Okay, anybody else need a calculator? You want one out right now. Okay, everybody got one?
Hey, this kid
Okay.
needs one.
All right, everybody got one? I want you to put 1.0 times 10 to the minus 7 in right now. 1.0 times 10 to the minus 7.
That's
10 to the minus 7, right?
wait, where?
Okay, just put it in. 1.0 times 10 to the minus 7. Now I want you to divide it by 1.0 times 10 to the minus 14. 1.0 times 10 to the minus 14. I purposely left something out because I want to see how many screw up.
Wow, that's a really big number.
1.0 times 10 to the minus 14.
This is not working.
Okay, how many got 10 to the minus 7?
I got one.
Oh, you got an error. Okay.
I got one.
Okay, this is a problem.
I got like 1 billion.
When you divide it by 1.0 times 10 to the minus 14, this needs to be in parentheses. If it's not in parentheses, it will mess you up. And this is the biggest mistake most kids make. And you'll end up with something that is times 10 to the negative 21st, right? That's wrong. So we need to make sure we times it, we divide it by this in parentheses. When you do, you should end up with 10 to the minus 7, or 1.0 times 10 to the minus 7.
I have that.
I got like a billion.
Yeah.
Even when I put it in parentheses, I got the same.
Okay, so you might not have it in scientific notation, you might have it right now.
Well, that's not gonna change.
No, it should be 0.00.
Yeah, we have,
I got a million as well.
no, it's,
10 to the negative 7 divided by 10 to the negative 14.
yeah.
That can't.
It's gonna get it.
Okay, it's going to be bigger, 10 to the 7. Sorry.
Yeah, I was gonna
Okay.
say.
All right, I got it.
'Cause they just flip sides and then you have 14 over 7. Which it just gives you.
Okay, now I want you to do the next one, because this is actually a number. Divided by 1.0 times 10 to the negative 14. Again, it needs to be in parentheses,
Wait, why are we times negatives?
because this is the equation I'm using,
Okay.
okay? So if I'm trying to find one of these two, I'm going to take 10 to the minus 14 and divide it by one of these two. Oh, and actually, that's why I've got it backwards
That's a
here.
big number.
That's why I've got it backwards. Stop.
Oh.
That's why you weren't getting what I wanted you to get.
You've done that.
I did goof you. Okay, so it should be 10 to the minus 14 on the top. And then divide it by 1.0 times 10 to the minus 7.
Wait, 10 to the negative 14? Or
Yeah, 1 times 10 to the negative 14. If you times this by 1, what is it? It's still 10 to the minus 14.
Yeah, okay, I'm just.
Yeah, that's why you weren't getting what I wanted you to get.
I guess
Should end up with 10 to the minus 7, right? Okay, let's do the same thing with this one. So I drop the 1 times whatever, because it's still 10 to the minus 14. So I just go 10 to the minus 14 divided by parentheses 3.8 times 10 to the negative 2nd. Give an answer.
2.631 negative 13. Times 10 to the negative 13.
I got to the negative
Uh-oh,
3 times
hold on.
10 to the negative 8. Yeah.
Negative 8 is right. Now, let me show you something really quickly. If I don't know if I'm off or not, if I take the exponent here and subtract the exponent down here, it should give me close to where I'm at.
It's a negative 2.
It's a negative 2, so it'd be negative 10, and I'm dividing 10 by 3, so this should be up a little bit more.
Yeah, it's
You're
negative
setting
13.
it up, is it just like 10 to the negative 14 divided by whatever the
Parentheses, yeah.
So that's
Yeah,
what all it
that's
is.
it, that's what all these are. But you gotta remember on the bottom that it's parenthesized, yes.
So, for number 1, is that one to be a
it should be negative
Yes.
13.
Yeah,
Should be
it's
negative 13.
And then also,
If you got negative 8,
Oh.
you would negative 7.
Okay, confidence with that one.
Kyle,
Can we
it's
just
not a 7. That's a 13. It's a 2.
Okay, my thing is freaking out.
Oh.
On the bottom.
oh, it is definitely a 2, you're right. Just said.
Okay, just a minute, I'm going to stop it and restart it.
You're sitting next to me.
Negative 13.
Alright.
It's like, what?
Apparently so. Despite the evidence that's wrong.
Okay, so let's try it again. So this 10, oh, as long as you remember the parentheses, you'll end up with the right answer. So we ended up with 2.63 times 10 to the minus 13 here, right? Okay, what did we get for the next one?
2 point.
1.0530 times 10 to the negative 6.
1.005
5 times
times 10 to the
Negative 6.
Okay, we're going to do the same thing here. Even though we're trying to find the OH and we've been given the H3O+. We're still gonna take 10 to the minus 14 divided by it, yes.
So on the first one you did 1, like 1.0 times 10 to the negative 14.
Right, and I did that because, now it's not showing it. Because this equation right here was H3O plus times OH minus yield 1.0 times 10 to the minus 14. But 1 times anything is what it
You
is.
can just do 10.
Right, right. And now it's not letting me go forward, now it's gonna put it in, okay, fine, go forward.
Okay, sorry, it's 35.
Yeah.
Okay. We're gonna do the same thing here, yes.
So when is this gonna be used, like in a test, what's the question gonna look like?
We're getting to them, okay. So I'm gonna go forward, because this side is just the same. Whether you're searching for OH or whether you're searching for H3O plus, 10 to the minus 14 divided by what you're given. Will give you what you need.
Wait,
Okay, but remember to put it in parentheses. That is the big thing.
so no
If you don't
matter-
put it in parentheses, you're gonna get the wrong answer.
So no matter what, we're always doing 10 to the negative 14. That's really small.
If you're trying to find OH or H plus given the other one.
Oh,
Okay.
Jesus, that's- you can't do.
All right, so really quickly here.
Straight up fraction.
Part A, what you were doing at home, had to do with pH, right? pH this is a scale that you had at home, right? And you were trying to figure out how much, were you more acidic at home, were you more alkaline at home, what did you have at home? Okay, that was part A. If it's less than 7, it's considered acidic. If it's bigger than 7, it's considered basic. If it's right at 7.00, it's neutral. If it's 7.01, it's basic. If it's 6.99, it's acidic. Barely, but it is. Okay? This is sort of gives you an idea of some things you might have tested and where they are on the pH scale. You had to sort of analyze what you did and put it into a scale like this, right? I had you, well, how many did you have at 7? What were they? Kind of thing. Okay? This is the paper that you just got. This is a shortcut. This is a shortcut. So I like to tell everybody to avoid this part because of those parentheses. I see so many kids screw up because they went across the bottom. If you go up and over, they do a lot easier. They don't have as many problems. So when I have a concentration, I take the negative log of the concentration, I get a POH. Subtract that from 14, I get a pH. Take that 10 to the minus pH, and I get the concentration of hydrogen. Yes, it's another couple steps. If you want to go across the bottom, that's fine. But remember your parentheses. Okay, yes.
And the 10 to the negative 14 will always be on the top, right?
10 to the negative 14, it's what this is equal to. So if I log this, it becomes this. So P just means I logged it. If I P something, I logged it. Okay?
Log like
LOG.
negative log.
LOG, yep. Negative log of it. Okay?
I heard this all over.
All right, so classifying really fast. What's this?
Neutral.
Neutral. What's this?
Acidic.
Acidic. What's this?
Acidic.
What's this?
Very
Basic.
basic.
Okay, you should be able to look at them really fast and be able to tell really quickly.
Opposite.
Okay, remember pH is equal to minus the log of the concentration. POH is equal to minus the log of the OH concentration. Really simple. The equations are the same. All you're doing is switching in H or OH. And remember, this is concentration. So this is an example in your notes. I'm going to go through it fast. All you have to do is plug it in, say minus the log, put that in. Do I have to put this part in? No. I can go minus the log of 10 to the negative 10. But guess what? It's 10. It is this number. If this number right here is a 1, it's just the exponent. That's it.
If what number is that?
If the number in front, if this number right here is a 1, then the exponent is my number. Just take the negative of it.
Okay, so if it's a positive number, it will be
It'll never be a positive.
a positive exponent.
Yeah, it will always be negative exponent.
So the answer
I
is
see, I
always
see. Okay.
Right.
Okay.
Okay? All right, so here's your second example. Now, because this is not a 1, I have to put that whole number in. But I know it should be close to a 5 when I get my pH. So that's my check. Quickly put this in. Negative log of this. What is it?
So do you just type it?
Negative log of that number.
7.4, right?
Yeah, negative to log.
Oh, all this.
Negative log of that number.
Oh, 4.75.
Yeah, see if you got it.
4.74 and 5.
Ta-da! 4.74. You got it. If we have two significant figures here, the pH always has 3. It's just the rule. Okay? All right. Okay, here's another one. This time you're given the pH, but you're asked to find every corner of that box that I gave you. Every corner. Okay, so, and tell if it's acid, base, or neutral. Since it's 4.5 at a pH, we know it's acidic. Now, I can start at that corner, I can go down. I can start at that corner, I can go across and down. I want you to really quickly see if you can figure out what the other corners on that chart are given pH is 4.5.
What?
Find the 4 corners on that chart.
Mine's at my house.
There should be some more circulating around out there. Okay, that should have been the easiest one, right? Now, once you got the pH and pOH, what do you have to do? Just 10 to the minus pH and 10 to the minus pOH, put it in your calculator, you got the others.
Oh,
Right? So 10 to the minus 4.5 will give me this number, and that is in concentration, so that's molarity. Go forward. Oh, I love my smartboard when it works. Okay, so there's your other one. How'd you do?
oh, you're right.
So all you do is go around the corners. Now, if I'm given, okay, as long as you're within 1 here, I'm going to be okay. All right, going forward.
Get the 3.2.
How did I get to 3.2? I put 10 to the negative 4.5 into my calculator. And that's a number that's popped in.
Higher. We got 3.16.
You got 3 point what?
You put 1.6.
1.6 rounds up.
I hate math.
Okay, now, they can give you this and ask you to find out if it's acid, base, or neutral. You've got to put it in pH. So wherever you are on here, you've got to find pH. So to get from pOH to pH, what do I need to do?
Subtract that from 14.
Subtract from 14. So 14 minus 5.25, I know I'm going to be above 7, right? So what is it? Base. 8.75. It's a base, right? This one, what do I have to do to get to pH? Negative log of it. But what can I do real quickly? All I'm asking is if it's acid, base, or neutral. Is that acid, base, or neutral?
Basic.
Basic. It's above 7. So I don't have to put it in. Does that make sense? It saves me a little time.
And then
Okay, what about this one?
acidic.
Oh, but be careful because this is OH. So if the OH is around 4, then my pH would be around 14 minus 4? 10. So this would also be basic. Okay, so I did really quickly. Did I do the math? Not really, right? But I just sort of flipped it through real fast. So you can watch this, but be careful. Because if it's not H plus, then it's OH and you got to subtract it from 14.
What is the 5.7?
The 5.7 will put it, so somebody throw it in, minus 5.7 times 10 to minus, or minus log 5.7 times 10 to minus 4. I believe it goes below. I believe it's like 3 point something, but it might go above. I can't remember. Either just to be out above or just below that number.
It's 3.2.
3?
Yeah.
So it went below. So it's just below this number. But it gives me enough. As long as this is at 6 and this is at 8, well, this one was, if it was 8, then I probably would check it. Okay.
Why is it a base? Because it is 3.2.
That's the pOH.
Oh, acidic or basic.
So then I've got it subtracted from 14.
So does that
Okay.
number, as it gets bigger, just change how much that number changes?
Right. Right. Okay, so going forward, really quickly, learning check. I want to see if you can do this. Find all 4 corners. Tell me if it's acid, base, or neutral. Four corners. This time you're given a pH of 8.3. Acid, base, neutral will give me the four corners. Okay, try and stay with us, and you know it's from the next page. You just got to finish this last little page until we get to salt, and then we're back in lab. So I'm just trying to hurry you along. About middle of the page right now. Did you get a card? Okay, try and stay with us so you won't get lost. Okay, I'm going to put some answers up. Don't look till you're ready. How'd you do? Thumbs up, I'm getting this. Thumbs down, I'm not. Thumbs sideways, sort of there.
So how to like calculate it?
So go this way. Since you have to hit all four corners, go here, and then get to 10 and then minus 10.
Are you right?
Okay.
So this is the answer. Yes. Go up along the top. I don't use the bottom. 10 minus 10.
I mean, we rounded.
Yep. Okay, we're going to move forward. We have to know a little bit because this is a medical chemistry class. Because this is a medical chemistry class, we need to know about the pHs of different parts of our body. So saliva, you can have a little bit acidic or a little bit basic, yes.
Do we have to know the strength test?
You need to know about. So most of the body is between 5.8 and 7. But the stomach
Wow.
is really acidic. So you need to remember that.
Do we need to know all that?
You need to know the basics. Okay, the basics.
Is that our basics?
Mm-hmm.
Okay. So that's our
Yes.
Okay, so this is like a kind of stupid question, but can the stomach acid eat through the stomach wall because it's so acidic?
It can if you get sores in there. Get ulcers.
You could
And it can go out into the abdominal cavity and start eating other organs. Okay, so properties acid, just basic. Okay, really quickly, we're almost there. Basic properties acid. Here you have an acid, it gives off a hydrogen, you have what's left over as a base, right? J, basic, basic, basic. Okay, for most acids, we're taking just one hydrogen off at a time. Just one. Okay? Now, this is the equation that we've been using for a long time. Okay? When we get into acids and bases, we're using molarity. So we replace molarity here. It becomes molarity of the acid, volume of the acid, molarity of the base, volume of the base. The only thing that we change is we now will times this by the number of hydrogens that we have in the acid and the number of hydroxides we have in the base. Now, if it's 1 to 1, we don't have to worry about it. And most of the stuff we're doing is 1 to 1. We don't have to worry about it. But there will be one question on your test that has a 2 to 1. So be careful. Whatever side it is where you put the 2. Okay, so if it's 2 hydrogens, you put it over here. If it's like CaOH2, you put it over here. Okay? Basic same equation we've been using for dilution is also used for titration. Okay? All right, how would you prepare? You need to be able to tell me, you need to be able to write this. So this is still C1V1 equals C2V2. How would you prepare 750 milliliters of a 0.5 molar sulfuric acid solution from a 6 molar solution? It says otter into water. You always put acid into water, like an otter. Okay? So, this is 1. D1. Oh, I got these mixed up.
He was.
Can we still do like
Ah. Okay, so you're looking for V2 here. I just rewrote it. Yes. Yes. Okay, so V2, so we got C1 V1 equals C2 V2. We're looking for V2. So V2 is equals C1 V1 divided by C2. Plug in.
I got 62.5.
62.5?
No,
5 milliliters. So what I would do, I have to explain how I would prepare. So I would get 62.5 milliliters of the 6.00 molar H2SO4, dilute up to 750.00 milliliters. Done. That's it. So when she asks you how to prepare it, solve for what you need to solve for, but don't just give her that. Okay?
That doesn't make sense. Can you explain that again?
So you're trying to make 750 milliliters of 0.5. You have 6 molar to work with. So you're going to take 62.5 milliliters of that 6 molar in a solution, in a thing, dilute it up to 750. When you dilute it up, it's going to become 0.5. Okay?
Wait.
6.2 or 62?
62, sorry. 62.5.
I got a 6.
You got a 6?
I got 62. I don't know, 0.5 run through times 750. Yeah. And then divide that by 6. Yeah, we should have 375 minus that.
Oh, I divided it by 60.
All right, going really quickly. There we go. I forgot I got it up there. There we go. 62.5 was right. Okay, there's one for you to practice on. I'm not going to, if you want to write the answer down so you can see if you got it right, I'll let you write it real fast. But I want you to try and get it on your own. Okay, so that's another practice problem. We are going back in lab. We need to move. So, grab your stuff. Around the corner, I put on another cart, your pH meters, your easy link, and your stirring rod. So grab what you need.
So I don't know.